All right, everyone, welcome and thank you for joining us for today's presentation, Understanding IP-Based Networks in the BAS Space. This is a really great time to be talking about this topic. I know all of us here in the room, and we're all here in the Johnson Controls headquarters in Milwaukee, Wisconsin, are really, really excited to talk to you about this today. All of us and all the speakers here, who I'll introduce in just a second, all had the opportunity to talk with a lot of you and your peers while we were at the ASHRAE show about a month ago, and we know that this is a really timely and relevant topic for everyone. So we're really excited to be able to present this to you today, and even more excited to be collaborating with Cisco, one of our partners, to deliver today's content. So today's agenda is pretty simple and straightforward. We're going to spend some time at the beginning talking about BAS IP-based networks, where we've come from, where we're at today, where we're going, some of the industry and market trends, that are shaping this landscape. And then we'll talk about specifically some challenges and opportunities within the IP-based space in the BAS world. Then we'll do a little bit of deep dive into the BAS networking topologies, pros and cons of each. We'll spend also a little bit of time doing a brief protocol analysis, and then we'll go over some common implementation examples with some of these different BAS networking topologies. Then we'll leave about 20 minutes at the end for Q&A today. And so even though that will be at the end, we encourage you to submit your questions either via the questions or the chat function in your GoToWebinar window at any point throughout today's presentation. And we'll do our best to make sure that we leave time at the end to answer those. We do have a large crowd with us today, so if for whatever reason we don't have time to get to your questions, don't worry. We'll publish a frequently asked questions document shortly after today's live event. Additionally, today's presentation is being recorded, so a copy of the recording as well as a copy of today's presentation will be made available to all of you and to any of your colleagues that may have registered for today's event but weren't able to attend. So again, a copy of the recording and the presentation will be made available shortly after the live event. So real quickly, I'm going to introduce today's speakers. So first we have Chris Lane, who is the Director of BAS Product Management at Johnson Controls. Chris joined Johnson Controls in 1992 and has held several positions in application engineering, sales, and product management. And in his current role, leads a team of product managers responsible for the Metasys product line. Mark Schultz is a solution architect at Cisco focusing on the IoT vision for smart buildings and is responsible for working with customers and strategic partners to capitalize on the value and benefits of a connected enterprise. Over the past 25 years, Mark's worked with manufacturing, industrial, public sector, and retail customers, connecting line of business initiatives with technology solutions. And last but not least, Mel Menke joined Johnson Controls as a senior product manager in 2015 and has over 30 years of experience in the communications technology industry. In his current product management role, Mel's responsible for all styles of communications networking, both wired and wireless. My name is Jane Walmsley. I'm a product marketing manager at Johnson Controls, responsible for our BAS portfolio, and I'll be facilitating today's discussion. So with that, I will turn it over to Chris to get started.
Great, thanks, Jane. So I think that a good way to kick off this discussion is to look at a typical building automation system network architecture and describe how the components have been wired together in the past. So I would say over the past 20 odd years or so, it would seem to me that the most popular or most typical way to network the building automation system components together has been to use what I call a two-tier networking topology, with the equipment controllers typically being networked together using some kind of serial RS-45-based field bus network, using three-wire twisted pair cabling, talking either BACnet MSTP or Modbus RTU, or maybe LAN, FT, or even some proprietary protocol like the legacy Metasys N2 protocol. And then at the higher level components, like the system controllers, the application servers, workstations, and workstation clients, those are typically being networked together using IP or Ethernet technology, wired together using Cat6 cabling and switches, and then talking either BACnet IP or some other kind of web service. This two-tier networking topology, consisting of IP-based automation network and then a serial or RS-45-based field bus network, has become a very popular way to interconnect the appropriate BAS components together. These technologies seem to provide a good balance between the performance needs of the components with their installed cost. So supervisory controllers and application servers are typically handling very large amounts of data, and as well as acting as web servers, providing rich graphical user interfaces to their client workstations or client computers. And these clients may be local or they may be remote, requiring some kind of internet access through a firewall or VPN access. So the choice of IP or Ethernet for the automation network is kind of a no-brainer. And on the face of it, the data transmission needs of the equipment controllers being much smaller and requiring much less capacity based on the types of data that they're exchanging, that makes the choice of serial-based technologies like those leveraging RS-485 a seemingly appropriate choice, especially given the installed cost savings of RS-485 or three-wire twisted pair cabling over Ethernet. But as the building automation system industry has evolved over time, the deficiencies of serial-based field bus networks have become more problematic. And for those installers out there, they probably know this, but one of the biggest headaches with serial or RS-485 based field bus networks is troubleshooting their issues, setting them up initially, getting them to work properly at initial startup, but then any type of issues that might pop up ongoing. Nodes on a field bus network are typically wired in a daisy chain fashion, where the three-wired twisted pair cabling is terminated at each node using a screw terminal. And you have to be very careful when terminating the network cabling at each node. Sometimes these field bus networks can develop an open or a short or a ground loop, and then finding those occurrences, finding those opens or shorts, can be kind of difficult, especially given the lack of industry standard tools that are available to troubleshoot those networks. I've heard of instances where people are actually dragging oscilloscopes out to job sites to troubleshoot those kinds of networks. We ourselves have developed proprietary field bus inspection tools to troubleshoot these kinds of issues. I know that there are other products on the market, but they're kind of disparate and no industry standard there. Some of the other deficiencies of serial-based networks is their limited bandwidth, which in the past may not have been a problem, but as more and more smarts start finding their way down to the equipment controller level, smarts like scheduling, alarming, trending, and even user interfaces, functions that were typically provided in the past by a dedicated supervisory controller and that are now finding their way down into equipment controllers. And as networks get larger and more complicated, the networks themselves can become too busy and start to slow down, and the performance degrades. Also consider some of the other trends that are shaping our industry, like integrating systems beyond just the HVAC equipment, such as integrating the building automation system with access control or intrusion detection, or fire control or video surveillance, lighting control, and so on. Or integrating other business systems or specialty systems found within a building, and then developing automation solutions around those systems. Also consider the Internet of Things, or IoT. Other industries are starting to catch on to the value of the technologies that our industry and the process control industry have been using for well over a generation. Technologies like interconnecting devices, sharing and analyzing large quantities of data, remote user access, automation solutions. Also, consumer IoT applications like home automation are constantly driving expectations higher, but they're also adding some benefit by driving the costs lower. We know that IoT adoption is on the rise and it's disrupting many industries. IoT is also bringing automation to new use cases that people have never even imagined before. And one sector it's revolutionizing in particular is our own building automation system industry. You know, before IoT, buildings used mechanical systems for environmental control, which were often prone to failure. These failures were difficult to detect proactively and led to poor tenant satisfaction. Building managers and owners became increasingly frustrated because the need for continuous repairs increased overall maintenance costs. So what we're seeing now is a growing trend leveraging IoT or IP-based devices that provide increased visibility and control over their environmental systems. IT managers and facility managers are now able to manage variables like temperature, security, access control, HVAC at their fingertips in real time. Not only can they control the devices, but they can collect valuable operational data as well. So as we move towards the buildings of the future, the trend will be to implement integrated environmental systems with built-in seamless automation. And data connected or collected from the IP devices will be instrumental in using to anticipate and predicting what settings and configurations will provide the most optimal occupant experience. So those trends really expose the weakness of using serial or RS-45 based technologies for networking the equipment controllers. Serial buses are somewhat unique to the building automation system industry, so they're not prone to being able to share them, the field bus network, with other building system networks. And the knowledge of field bus networks resides mainly in the building automation system industry, so you can't leverage outside expertise like our friends in the IT department or suppliers to the IT departments to help with the installation or servicing of those field bus networks. So as a result, many vendors, including us, are starting to provide building automation solutions that leverage IP or Ethernet networking technologies across the entire network topology, even down to the equipment controller networking layer. This solves many of the deficiencies of serial RS-45 based networks. Ethernet connections used crimped RJ45 plugs, which seem to provide more reliable node connections than screw terminals. Ethernet also has a much higher bandwidth, eliminating slow or busy networks, and IP Ethernet can handle multiple networking protocols. So your physical networking infrastructure can be shared to converge with or to integrate with other systems. And Ethernet's also been used and will probably continue to be used for most of the commercial buildings' IT networks. Those are the networks that interconnect the computers, printers, and phones within a building. And there's lots of expertise that already exists for that kind of technology, that IP Ethernet technology, within the IT sphere. So for customers who want to future-proof their networking infrastructure, IP Ethernet is quickly becoming a very popular choice for even field bus equipment controller networking. Now, there are some challenges and opportunities with using IP Ethernet down to this layer, and it has some issues of its own. From a topology perspective, Ethernet has different rules than serial or RS-45 based networks. Nodes on an Ethernet network can be connected in a star topology, where the Ethernet cable is run from the switch port to the controller node. Daisy chaining, which is predominantly used with serial-based networks, is an available option for Ethernet as well to reduce the amount of Cat6 cabling, as well as reducing the number of required switch ports. But daisy chaining Ethernet has some network resiliency issues that Mel and Mark will share a little bit later here. So we're starting to see newer technologies like media redundant protocol and ring topologies emerging to provide a balance between the installed cost and the network resiliency of Ethernet-based networks. So now I'd like to turn it over to Mel and Mark to dive into more details about those, as well as other challenges and opportunities with IP-based BAS networks.
Thanks, Chris. As we continue to move more of the building automation systems, or BAS, into the IP domain, there are challenges to consider, but there's also opportunity. Unlike the mechanical control systems previously used, IP systems are vulnerable to cyber attacks. And I would expect everyone to have heard of a case where a business was negatively affected due to one of these cyber attacks. These attacks can propagate through an entire network if not properly mitigated or contained at the point of attack. Mark, based on your years of IT experience, what are your thoughts?
Well, thanks, Mel. The whole concept of IP devices becoming under attack is not new or unique to the building automation system. This concept applies to IT devices and actually us as users on an IP-based network. It all starts with developing a good security profile at the device level, but then also at the network level to correctly configuring a secure network to help reduce the threat footprint that these devices are exposed to.
Well, we all know we have to take security seriously. Considering the second point, implementation of these IP devices can be cumbersome and expensive. With more and more of these IoT-focused devices becoming available, you now have to think about the implementation of a network infrastructure to connect them all together. This means deploying IP equipment that you are not typically used to doing, and you now need to involve IT with the help and implementation and maintenance of that network. When this network design and implementation happens, these new stakeholders, such as IT, if they're available, will need to buy into the plan. And probably more impacting to the installation is that all of this coordination to integrate these systems together can then create operational complexity. But these newer systems are critical to ensuring your occupant satisfaction and your continued success.
The introduction of the new Internet Protocol-based building automation devices and network creates a whole host of collaboration options within the organization. These devices will need cable drops. They will need switch ports, IP addressing, security rules, all bringing it together under one focus of enhancing the building owners' profitability and ease of administration, but as well as the building tenants' comfort.
I agree. We have to remember that these challenges, they come with opportunity. With a wealth of data from all of these integrated building systems that you mentioned now available, it can be converted into actionable information and can then be used to manage the building automation system at its peak performance. And ultimately, that is the goal that we all want to achieve. So now let's take a look at the pros and cons of the various BAS networking topologies that Chris mentioned earlier. Here is a more focused view of the network topologies that Chris mentioned earlier. So let's go into each one of these a bit more to discuss how, and then the pros and the cons. The three basic topologies typically used in a BAS control system: daisy chain, star, and ring. On the left, we have a BACnet MSTP daisy chain, which some may also call a BUS. It has historically been the communication method of choice at the controller level, and usually over a 3-wire twisted pair cable. The challenge with this daisy chain configuration is that a single link failure means all of the downstream controllers would stop communicating. Another challenge is that the MSTP cabling is lower bandwidth, so large amounts of data can overwhelm the network, reducing its performance. One thing to note on this slide is that all of the network topologies eventually all utilize Ethernet and IP at the supervisory level. So Ethernet-based communication is not new to BAS. It's just being brought down to the controller, and in some cases, even to the sensor level. Now let's take a look at the Ethernet-based IP solutions. As we start to use Ethernet BACnet IP for communication to the controllers, you now have the choice of star, daisy chain, and ring. So let's look at star topology first. In this configuration, all of the IP controllers would have a separate Cat6 Ethernet cable connected between the aggregation switch and the controller. Sometimes this is called a home run style of cabling. While star topology provides high resiliency, it would also have a higher cable and installation cost, as well as an increased number of switch ports and addresses that would be required of IT. Ethernet-based IP daisy chaining is similar to MSTP daisy chaining. Here you would connect Cat6 Ethernet cabling from the aggregation switch to a single IP controller, then run cabling from one controller to another controller, continuing until the last controller. While daisy chain topology is more cost-effective than star topology, as it reduces the cabling and the number of switch ports and addresses needed, it is not as resilient as star topology. Again, this is because a single link or controller failure would mean losing communication to all of the downstream devices. So let's talk about Ethernet-based IP controllers configured in ring topology. With ring topology, you are adding a managed industrial switch at the beginning of the traditional daisy chain and then connecting another cable from the last controller back to the aggregation switch. In all simplicity, you're really just creating a communication ring using Cat6 cabling, and then this ring network is managed by a switch. This provides a nice balance between the installed cost and resiliency, the pros and cons of the other topologies, such as star and daisy chain. Another point to consider, and was already mentioned, is that a challenge of IP networking is more integration with the IT department. However, asking IT for support to integrate an industrial switch that they are probably already familiar with, and it supports IT quality security, should make that conversation easier. And asking for fewer switch ports and associated IP addresses can't hurt anything either. Now, one final point when talking about Ethernet-based IP rings is the value of future-proofing your network. We have a great example coming up to show how future area and controller expansion when using a ring can be accomplished with limited or even no interaction with the IT department. So just to summarize these network topologies that we've discussed, star provides high resiliency but comes with higher installation costs. Daisy chain, it provides a lower installation cost but with only moderate resiliency. And ring provides the highest resiliency with the lowest installation cost. So Mark, let's take a little bit more of a look around ring topologies that are available.
Thanks, Val. The ring technologies available to the BAS space here aren't really new, but let's do a walkthrough of the various technologies. Let's start with the oldest technology first, which is Rapid Spanning Tree Protocol, RSTP. This was an open standard developed in early 2000, primarily for IT networks. When IT networks started, there was a need to interconnect them together and multiple paths were created. Spanning tree was the solution to prevent loops from occurring in the network and data being lost or confused. It employs a method around variable convergence time. So whenever there's a break or a new member of the ring, there's a calculation that goes on. And the calculation is based on a host of variables, including items like MAC address, operating system, and some also variables which are configured in the operating system. The next ring protocol I'll discuss is Media Redundancy Protocol, or MRP. MRP was developed around 2010, and it was developed for industrial networks. And when I say industrial networks, think of a plant, think of an oil refinery. And one of the key use cases for the MRP protocol was the introduction of life and safety. So if we're talking about life and safety, variability is not allowed by any means. Because of that, it has a very deterministic ring convergence time, which means it's centrally controlled, based in hardware, to control who has the master of the ring and the timing involved in it. Again, very deterministic, very fast. A couple items I'd like to introduce you to on this chart. The first item is a bidirectional watchdog packet. And if you look over at the left-hand side of the slide, you can see those little P packets going around. The way I like to talk about watchdog packets are hello. When we meet somebody, it's very common for us to say, hello, how are you doing? Think of that as a watchdog packet. It's very conversational, very low overhead, allows everybody in the ring to know what's working and what is not. The second thing I'd like to call attention to is the IT room off of the ring. The ring as we defined can be installed without the IT connection. And when you add IT, it's a very simple process to go through, which we're going to go through in a case study in going forward. I'd like to now go ahead and deep dive into how the ring topology works for MRP. This industrial switch we see up on top is a device without a fan in it, so it can be installed in a non-conditioned space. It's also something that has a mean time between failure measured in decades, not in months. So we have this hardened switch that is available to us. So the hardened switch simply sends a watchdog packet out, again, the hello messaging, to see if the ring is up and available. Again, a little hardware chip in this industrial switch goes ahead and communicates to all the controllers around the ring. And then you see off to the side, there's a supervisory controller that takes all of the building data in, the temperature reading, the duct motors, everything required for operator comfort, and make sure it works seamlessly. Going forward, somebody cuts the cable. What happens now? The industrial switch quickly realizes its hello packet is not transcending around the ring. So immediately a redundant path is opened. And you can see the hello packets go a different way around the ring. The switch notifies the controllers of the change and they begin failure. And the failure is limited to the node. Note, during this failure crisis, the application, comfort, or the efficiency of the system is not jeopardized. There is no variable convergence. It's all predetermined on a threshold to impact none of the important people in this equation, which are the humans and the building owners. And finally, we're going to show what happens when the link is restored. The timing is just as quick. When a failed link is restored, the normal state begins. The IP controller is notified of the status change. The block port removes to its original state. The beautiful thing of this MRP solution is centralized control of the beacon, which makes for simple configuration, which we're going to talk a little bit about some of the differences coming up in the next slide. On this slide, we will start with a brief high-level comparison of MRP and spanning tree. Let's start with the failure, which is recovery from that broken cable, which we saw. In media redundancy protocol, it's measured in milliseconds, and it's deterministic. It's based on a single processor, which is the master controlling it. In spanning tree, it's somewhat variable, and it relies on the determination of something called a root bridge, which again, the reason it's variable is it's based on a lot of different elements in which some of the variability can be minimized through some extensive configuration. The next item I'd like to talk about device support. If we look at simplicity and fast failover, that yields its way for large device support. The device support on MRP is at 100 nodes per ring, where if we look at typical rapid spanning tree, 40, most deployments are somewhere around 20. The 100 number is substantially larger than traditional MSTP deployments, making it more affordable. The other part, as we continue to look at first in cost, what it costs to get the system installed, the configuration time is a huge concern of any building owner or contractor involved. That's why with MRP, single ring manager to configure and deploy, actually it's so simple, it's possible to have that process fully automated to set that up. Versus a spanning tree protocol, as I mentioned earlier, there's lots of variables, lots of options for configurations, and as software versions change, spanning tree variables change. So it's pretty hard, complex to do that. Then let's talk about the skill set of that. Skill set in the smart building industry, the first in cost, depending on what level of technician skill set you have. It's pretty simple on a MRP ring. And actually, as far as when an MRP ring fails open, or closed, it actually creates a physical LED light on the switch, versus a spanning tree failure event requires IP knowledge to know a failover. And Chris mentioned earlier about analyzers. To look at a spanning tree storm, you may actually need a sniffer to sniff the network and see it. You have a much higher technical skill set required in that example. Quick comparison of the two protocols. Next, we're going to go forward and talk about some use cases.
Thanks, Mark. So let's highlight some installation scenarios where an IP ring network can reduce installation time and complexity. And we all know that translates into reduced costs. For this first one, I am adding a new wing to my building, and we are going to use IP controllers to integrate with the IP network already in my existing building. Mark, with this new ring manager solution, what steps are required?
Well, it's actually really simple. It's just a couple steps. So we see, if we start on the right-hand side of the diagram, we're adding this new part to the building where we need a new air controller. So we put that in, install it, mount it, get it powered up. Then what we do is we simply open the ring, and when we open the ring, we notice, just like before, take the existing RJ45 cable out, insert the new cable to the controller. There is no application failure. There is no disruption of the user or the data. Then we connect the other end of the controller into the ring, and the controller seamlessly gets an IP address from the switch. It has its existing security profile installed to create a security zone for the network. And again, there is no disruption to the users, no disruption to the data flow, or no involvement from IP. The same security profile applied across the ring to the new controller as the existing one. It's really pretty simple and straightforward and not disruptive to the rest of the building.
That sounds like a perfect solution for retrofits and expansions. Let's talk about new construction. Okay, for this, what I'm going to show you is an example of new construction. And yes, you're seeing correctly, as this page is blank. That's because I don't have a building yet, but when I do, I need to provide an installed, tested, and ready BAS system before occupancy, and as always, my timelines are tight. But here's the challenge. I can start to build out the BAS, but IT is not even available yet to complete the network. Additionally, their networking system components typically require a functioning HVAC system to maintain an environmentally controlled space. I can always install a temporary network, but that just adds cost as well as time to the project. So based on what we've said here, it sounds like I can use this Ethernet-based IP ring network to get my HVAC and other systems up and running even before IT arrives. Mark?
Absolutely right. This vision painted out here can be completely self-contained before the HVAC is installed to keep the IT switches with fans and these great server racks cooled. So as we add those additional IT resources, the heating and ventilation to keep those rooms at the peak humidity and operating performance can be added. Now you notice, once IT is connected to the IP network for the building, we induce a whole host of options, moving the application servers to a virtual machine under IT management. And the beauty of it is we only require a single link with a couple of IP addresses to enable this. So we simplify this from the IT perspective. We give them their functionality and the lifeblood, what their gear needs, which is cool air to keep them cool in the wiring closet. Plus, remote access is maintained throughout the project.
Well, with my tight timelines, that sounds like a perfect solution that'll get me in that building faster.
Yep. So that's great, Mark, Mel, Chris. Thank you so much for walking us through that. So I think now that we've had some time to go over all the different implementation options, some use cases, the different protocols, the different topologies, we wanted to do just a quick poll with our audience today So, and then we'll turn over to Chris for some conclusion remarks. But after today's presentation and what you've seen so far, we want to know, what are any remaining barriers you see in implementing an IP-based solution? Cost, lack of expertise, risk, or compatibility or lack thereof with the current installation. So we want to hear from you. We'll give you just a minute or two here to answer the poll. All right, we'll give just another couple of seconds here, and then we'll go ahead and close the poll. Let's get those results up there. So it looks like a lot of you are saying any remaining barriers. It's kind of a tie between lack of expertise and also compatibility with current installation. So thank you for that. That's really good to know. So I think now that we've got our poll results, Chris, we'll turn it back over to you for your final remarks.
Yeah, so I guess I want to conclude with, what does this really all mean to either a building owner or a consultant working on behalf of the building owner? What should you make of all of this information that we provided you? Well, one of the things that we would suggest you consider is how to create the use cases. So in other words, how to create a more connected experience with a unified and simplified BAS network. Because by harnessing your data, you'll find that you can create an experience that takes your building to the next level. Incorporating a solution that delivers this means implementing a streamlined and robust system. And once available to your building's ecosystem, you're now able to tap into enhanced visibility, which allows you to manage at a more granular level of control. And at this point, you can access data that brings your strategic objectives into perspective and your projects into focus. And doing this requires a higher level of security, because when you gain insight into this large pool of data, it becomes vulnerable to outside threats. So having integrated security will protect your critical insights and reduces the likelihood of being hacked through both physical and virtual systems. So a unified and simplified network that then takes into account how you can scale. Imagine seeing all critical aspects of your business at all times when needed. This can only happen with a streamlined and robust system. Technology like this does not need to equate to more physical equipment. However, it can be done more efficiently, meaning less IT overhead and management for your staff. Your IT staff would thank you as they go on to complete more higher priority tasks. And you want your building's network to ultimately work for you instead of having you work for it. And then for those of you that are considering, well, who can provide such a solution to me? Some of the things that you should consider when deciding on selecting which IP-based offering or which provider is best suited to your needs. Some of the questions that you may want to consider. Does your provider have an extensive IP controller offering at all layers of the building automation system architecture? Does it support multiple networking technologies, including the ones that we outlined in detail today, like MRP? Does your provider have an extensive offering of multiple networking topologies that will allow you to provide different IT technology providers? Have they partnered with leading IT technology providers to help you implement some of these solutions? And what kind of configuration tools do they have that makes configuration easy and cost-effective? And do they have proven integration capabilities that span entire building systems, covering not only the HVAC system, but also non-HVAC building systems, business systems, and specialty or vertical market systems? And how involved are they, and how much influence do they have with industry standard boards so that their solutions are implemented in a non-proprietary way? Those are just a few of the criteria that we recommend when considering which provider and which technology can truly turn the promise of a smart building into an affordable reality.
All right, thank you, Chris. Great final remarks for our audience today. So we've got a lot of great questions coming in, but we encourage you to continue to submit those in our last couple of minutes here. As I said earlier, we'll make sure to address any unanswered questions in a follow-up communication that will be sent to all registrants after the live event. And also, just as a reminder, a copy of today's presentation will be made available, as well as a recording in that same follow-up communication. So again, if you want to revisit this content or share it with your colleagues who may not have been able to attend, we will certainly make a copy of today's presentation available. So with that, we'll get right into the question and answer portion. So the first question for our presenters is, when using IP ring or daisy chain, are the controllers set up with 2 ports? If not, what is the wiring pattern?
Yes, typically controllers that are either daisy chained or put into a ring topology will have 2 onboard RJ45 ports right on them. So there's no adapter or anything. The controller itself handles the connection of the Ethernet cabling.
Okay, thank you, Chris. And are there distance limitations for MRP or RSTP segments?
So the beautiful part of the MRP protocol is it allows for standard Ethernet distances to be deployed, which is 100 meters. So it can be deployed via the standard punch-down methods or actually a direct cabling between it if your devices are within. So the standard answer is 100 meters for standard copper cabling. Fiber could also be deployed, which would increase beyond the 100-meter length, and then fiber will depend on the SFPs used and the type of fiber for the length. But both physical medias are supported, and we're well within the spec of 100 meters for the MRP solution.
Great, thank you, Mark. So can the controllers that we showed in some of the diagrams and network configuration examples, can those be used with a different branded air handling units or non-Johnson Controls air handling units?
Yeah, so I think that the equipment is typically separate from the controller that's operating that equipment. So it's really the controller itself that needs to have the technology that supports the networking technology. So in that case, you know, a Johnson Controls equipment controller can be applied to any brand of mechanical equipment, whether it be an air handler or VAV box from York or from another competitive mechanical equipment supplier.
Okay, great, thank you. Can an RSTP or MRP IP-based ring topology be used directly connected to the IT network switch, or is the industrial switch required to make the ring topology work?
Great question. The industrial switch actually contains a hardware chip to enable the MRP ring technology. So a standard off-the-shelf IT switch does not have the ring master running in it, so you would not be able to directly connect a ring into an IT class switch. However, the industrial switch is an easy connection to any IT switch. The operating systems are very, very similar. They're the same operating system. There's just a difference of this additional hardware on the industrial switch to enable the ring technology.
Okay, great. Thank you, Mark. In the retrofit example that you walked through, when adding the equipment controller, is the industrial switch sending a message to the network that requires an additional IP address, or is some programming involved at the industrial switch level or programming all the way back at the network level?
The default implementation for this type of solution would be the industrial switch controls and responds to the DHCP request for IP addressing. So it's quite simply, as you add a controller, or in our example, Mel and I just walked through adding 1 controller. Let's say you needed to add 10 more controllers. The process is the same. The controllers do a DHCP request simply to the industrial switch. It responds with the IP address, and the ring is enabled. It's very simple, straightforward, without involving IT and without manually setting anything up.
Okay, great, thank you. Is Power over Ethernet supported in the MRP architecture?
So from a technology standpoint, Power over Ethernet is primarily deployed as a star topology because in current standards, there is no way to daisy chain PoE. With that said, the MRP industrial switches do have PoE options for star configurations.
Thank you, Mark. Is it possible to make the ring or MRP-based solution using fiber optics?
Yes, it is, and it has been tested and validated. And the failover time is very, very similar based on the assertion time of the optics into the SFP versus the copper. So you still get that millisecond failover time.
Got it. Thank you. And how does this kind of solution compare to a wireless network solution like mesh networks?
I would say that from a mesh networking perspective, where you basically have multiple routes for a message to make its way back from the end device back to either a coordinator or a gateway onto the network, the ring really is it's based around a defined cabling from a controller to controller, but as mentioned, when you lose a controller or you lose a link, the ring will automatically send those watchdog packets the other way around and essentially have no effect on the piece of hardware. So it does add some level of redundancy from a controller perspective that way.
Great, thanks, Mel. And could someone test the ring solution without a workstation?
So that's kind of the beautiful thing about the MRP. The MRP was actually designed to be tested or troubleshot without a technician actually having a workstation, because one of the core things around the MRP is the total cost of the solution, including first in. It's not viable to have a tech running around with a laptop plugging into all over in a building that isn't space conditioned yet or maybe even closed in. So there's a simple LED light that will tell you the ring status of the switch. So to answer your question, very simply, yes, it can be done without a workstation.
Got it. Thanks, Mark. And just to confirm, do the IP controllers work only with a workstation, such as like a VAB?
Not really understanding the question. The ring network is really talking between the physical controllers that can then be supervised by some other device, including, like a network engine or an FX supervisory class controller. The server is typically an optional component that rides on the automation network, not on the field bus network.
Thanks, Chris. Does each controller in the ring solution have an IP address?
Yes.
Great, thank you.
And I think there was a question about how many IP addresses
yes.
that we can support within the ring and how many you would need to apply from the IT department to the switch.
That's a great question, Chris, and that topic requires a little explanation. So let's take some time and go there. So in standard installation, each switch can support up to 3 rings of 100 devices each. So we're talking 300 IP addresses, plus you have a controller, maybe a secondary controller, and all those DHCP assignments normally are handled on the industrial switch, so it allows those out. But then as we get back to the IT network, we need a couple of IP addresses that comes over the connection back to the IT. So from an IT side, we really only need a couple of IP addresses. However, the entire, what I like to refer to the potentially standalone building automation system can support hundreds of IP addresses that are all administered via the server, a DHCP server that resides exactly in the switch. And because the MRP protocol is so simple to configure, it's completely possible that all the configuration for the MRP protocol, the master and the client connections, as well as the IP addresses and the security rules, can be completely automated, so you don't even need to type it into the switch. It can be automated at provisioning time.
Great, thank you. And just to be clear, Mark, how many rings per switch are supported?
3 rings of 100 nodes each per switch.
And how many ports are on the industrial switches?
That's a great question. The portfolio of industrial switches go anywhere from a 4-port switch with a couple uplinks to an 8-port switch, and there's a 16-port, and then there's a 28-port that all support the industrial protocol. Based on a lot of building simulations, sort of the sweet spot was determined as an 8-port switch would be best for most buildings because it gives access for the rings as well as access for other devices that may be connected for a star. But it's totally based on the customer needs of the installation, and there's options available within the MRP solution in supporting different switch capacity.
Okay, great, thank you. And when you were talking about the different cable length measurements, is that for the entire ring or for each segment?
Each segment.
Okay, great, thank you. We talked a little bit about IP addresses. Can you go over again how those are assigned? Is it done by the larger IT network or on a lower network managed by the industrial switch?
So the answer is it could be done by both based on implementation. The MRP doesn't dictate one way or the other, but most building networks will probably be defined at the local building network ring architecture. So actually the switch will become the DHCP server, and the configuration of the DHCP server simply can be automated. So just from a workflow standpoint, the individual controller will make a DHCP request, and the industrial switch supporting the building industry will answer that request, providing an IP address back to the controller without ever going to IT for an IP address, making it very, very simple to integrate with the information technology department.
So if there's like IT restrictions on how many IP addresses that they'll grant out, this would be a pretty good solution for that, because they would only have to hand out maybe 1 or 2 and let the switch handle the rest of the IP address assignment.
Absolutely, and that simplifies it. It simplifies it for the building management team. It also simplifies it for the IT team. And it provides a very scalable way of making a secure network available.
Great, thank you. So when we're looking at the IP daisy chain topology option, if an IP controller fails, is the communication broken at the failed controller, or is the communication still intact?
If it's just daisy chained and not using the ring topology, then yes, the communication between the downstream controllers would be lost if the controller goes offline or is not powered.
Got it.
And that's what the MRP is intended to resolve, is to provide that redundant pathway so that a single failure occurrence doesn't bring down all the downstream controllers.
Got it. Thank you, Chris. If the ring is broken at 2 points, does it give you a signal indicating the location of the open CKT?
There are SNMP variables sent out, alerts sent out, as well as the alarms will change on the switch. The actual location depends a little bit on the implementation, as far as how easy it is to zero in to that exact place in the network.
Okay, great, thank you. In the ring solution, do you need to go through an engine or a supervisory controller, or can these talk directly to a server or the ADX?
It depends on your architecture, but typically these devices are talking like a BACnet protocol. So whatever device is supervising them needs to also be talking the BACnet protocol. And that traditionally, in the case of like the question is kind of alluding to in the Metasys architecture, that is typically to a network automation engine, either like an NAE 55, or it could be an NAE 85, which is one of our soft engines. Our application and data server doesn't talk BACnet, it talks web services to those engines, so they're not talking directly between the controllers and the server. Now, there are other systems, like for example, that have BACnet drivers at application server layers that could then talk directly to one of the nodes, and then that would then talk to the other nodes within the ring. So it really all depends on the types of components that you're using in your architecture, the protocol that they need to speak in order to communicate is BACnet.
Got it. Thanks. Thanks, Chris. So we have just another minute here, and I know that we have quite a few questions still coming in. So again, we'll make sure to address all your questions that we didn't have time to get to today. But our final question is, does the ring topology solution allow power resiliency for the controllers?
The industrial switch can support multiple power supplies.
Okay.
So we can, at the brain of the solution, you can have multiple power supplies on the industrial switch, as well as alerting and alarming during a failure situation of a power supply even, as well as lights on the switch to make it troubleshootable without a given workstation.
Great. Thank you, Mark. Thank you, Mel. Thank you, Chris. I think with that, we'll conclude today's session. Again, I know we still have a lot of great questions coming in, so we will make sure to address those after today's live event. Thank you so much for your time. We know how busy you are. We really appreciate you participating in today's session with us. We hope you learned a few things. We have already seen a few folks submit some forms using the URL that's on the screen here. So again, if you have any other questions or you'd like someone from Johnson Controls or Cisco to follow up with you, we invite you to encourage the URL on the screen as well. Thank you so much, and have a great day, evening, or morning, depending on where you're at in the world.